Um, so it's kind of weird in terms of, like, section 5 is all about graphing. Has almost zero to do with this section. So what's happening is we're at the end of derivatives. And everything's not necessarily sequential at this point. So we're kind of just trying to do every type of problem that involves derivatives. And so that's how this works. I would say 5 and 6 could have been swapped and you wouldn't have noticed a difference. We probably didn't do 5 last because most students feel that one to be the most difficult because it's got so much stuff. But it's, I don't know, 6, in my opinion, these questions are easy. But I also know a lot of students look at word problems and they immediately feel like that's like a barrier, like your defenses go up when you read a word problem because you feel like it's a harder version of a normal problem or something. And I kind of get it. Just doing practice at them and trying them is what makes them feel easier. So these are called optimization, which absolutely is just going to be a better word for maximum and minimum in a word problem. I shouldn't even say better word. It's a single word. Thank you. I only have tiny Post-its, so I'm going to do my best to fit it. Oh yeah, okay, so we'll start off with the easy ones. I say easy because they're just very little to work with. Like they're supposed to be semi-straightforward. Find two positive numbers, I should have started with that. Find two positive numbers such that the sum of the first and twice the second to 64 and whose product is a maximum. I have had students in the past try to brute force this by just writing down numbers until they figured it out. I wouldn't recommend it. It'd be a good way for you to basically check your answer, though. I mean, there's nothing wrong with that. If this ended up being a free response question on the AP test, they would look for the correct steps, and that's where majority of the points would be. So you possibly could get a point for the correct answer by just coming up with the right numbers. So when all else fails, that's not like a bad option. But for most free response questions, they want to know you're doing it the right way. So let's start with this. Within the problem, it's going to have to say something is a maximum or minimum. Like that's what identifies this as an optimization question. There might be indirect words. I'm not even sure the correct grammar for that. It'll say infer, probably would be the right word. It'll infer that it's supposed to be a max or min without saying it directly. So you kind of have to just read sentences and know what it's asking for. I'm going to set these up slightly different than the packet. So if you don't like my way, you could certainly just try the way that she sets it up, which isn't terribly amount different. It's just different kind of phrasing. So what I usually do is I usually have a primary and a secondary. And I like doing it this way because it helps me mentally separate information. And so I kind of keep straight what's supposed to be used for what. Your primary information / equation is always going to be the max or min question. Like, that's what you're trying to answer with what should be maximized, what should be minimized. That's what always identifies primary. This one says whose product is a maximum. Okay? I'm just going to multiply two numbers. You can call them whatever you want. Now, the max and min isn't something you generally need to write down. Like, we're going to go through the process how we have done it previously to finding a max and a min. If it's a closed interval, we're going to do the process for finding absolute max, absolute min. If it's an open interval, because these problems can be either or. If it's an open interval, then we would look for relative maxes, relative mins, slash, try to figure out if it would be absolute or, like, each problem is going to be somewhat different, but we approach it the same way we did maxes and mins before. So it's the same extreme situations. Generally, the primary that you're trying to solve can't be solved on its own. And so there has to be a second source of information for you to be able to figure this out. And so that's what I usually consider the secondary, is what you're using to help you solve the primary. This sentence or problem really only has one other thing written in it. And then that's talking about the sum of the first and twice the second is 64. So that's what we're going to use to try to figure out over here. So, like right now I've got it in two variables, but we can't really figure it out in two variables because of that. So, sum of the first, who should we go with? Fernanda, have I called it? I haven't called on you for a while. Anything you can tell me about what I underlined in blue? How about that first word? Yeah. Add, okay. I assumed you knew it. I was just figured I'd go with it. So as soon as you see the word sum, that means we know we're trying to add two things. What are the two things?
X and Y.
Okay, so I would just do x plus y. You didn't sound so sure on that.
I don't know, like, twice the second, like this session.
What are we identifying as the first number and the second number? Because that's what it's kind of referring to. I'm going to guess because you said x plus y, in your mind, x is the first number, y is the second number. Okay? So if we just kind of read that sentence as it directly says, it's trying to say the first number plus twice the second number is, and then is was the word representing equals. Yeah, 64. So is are, I'm trying to think of another word off the top of my head. What's another English word that represents is and are? I feel like you guys are doing just as well at English as me. Any kind of words that represent equals. Is and are the two most common. I mean, like, that's what you usually see. Fernando, who are you going to call on? I can. I was making you choose. Andrew? What do I do from here? Like, any thoughts? I got two things written down. I don't know how that helps me.
Would you solve for y so that it'd be like a function?
Okay. Oh, just to make it look like y equals function?
Yeah.
Not a bad thought. I'm not going to do it exactly like that, just because it would be slightly harder, but I could. So if I did solve for y, I wouldn't write this down. If I did solve for y, this would say 64 minus x over 2. Or you could, make it 32 and a half x. What benefit would that do? I'll just leave it for anybody if you're not sure, and that's fine. Like, how would this help us?
Then you could plug it in for y.
Oh, okay, so substitute it. Yes. So our secondary equation information, we're always going to use to help us solve the primary. Generally, that means make the primary into one variable. So Andrew first started by saying solve for y. I'm assuming you're just kind of going out of habit, like from normal. If I were looking at this equation, it's going to be a lot easier to solve for x. So you theoretically can solve for whatever you want, but keeping the problem simplest for yourself is going to help quite a bit in terms of working with like derivatives and things like that. So I'm going to solve the secondary equation for x and then substitute that into the primary. Now, I guess there are situations where maybe this would be beneficial to solve for a certain variable, because maybe up here, like it's asking us to find both answers, but maybe it would only ask us to find the first number. And so then we would want these variables to be x's so that we could just find the answer right away, I guess. That'd be about the only thing I could think of. Okay, so product equals 64 minus 2y times y. Magdalene?
Would you find the derivative of that when it equals 0?
Why?
Find the maximum?
Oh, okay. So we've got an equation, and the way that we're going to find maximum, which is kind of the goal, is to do the derivative equal to 0 or undefined, and then kind of go from there depending on what situation we have. This theoretically does have domain restrictions. Neil, what can't our answers be?
You can't have a 32 for y.
Say what? Are you getting that from twice the second?
Yeah.
Oh. True. I mean, like, it's not wrong. You overlooked the obvious one and went with the hard one.
Can you not have negatives?
Yeah, that's really all I was looking for. I was trying to think of what to say that would try to lead you to it. It says two positive numbers, so you can't have any negatives. So we do have restrictions. So like our answers can't be negative. What you're saying about the second number can't be bigger than 32 is only true because you can't have negatives. That's why it was a harder answer. Because if you could have negatives, they could be whatever. Tyler? What would you do from here? So our goal was to take the derivative and set it equal to 0 undefined. And no, there's not much room here for me especially, but maybe for you guys it's better.
When you said you're using the derivative.
Yep.
and maximum,
Yep. So would you just do derivative as is?
yeah, I guess.
Okay, you can. So how would we do derivative as is?
Well,
This is the benefits and the negatives of word problems, is that we're at the stage where you guys have learned everything you are going to know about derivatives. And so you kind of have the freedom to choose options on how you want to approach something or do something. But sometimes that's not as good because it feels like you don't really know what direction to go. I'm guessing that's where you're kind of getting stuck. Okay, so if I'm looking at this, I would see a product because I've got a parentheses times a y. So I've got a variable times a variable. So if I were doing derivative from here, I would do product rule. There's nothing wrong with that, but that's definitely harder in my opinion. Like, what could I do first before I do the derivative. Do you want me to pass it on to somebody else? Because everything you said so far was correct, and if you couldn't think of something else to do, you could certainly just do product rule and it would still be correct. Hannah, are you trying to help him?
Yeah, would you multiply the y out?
We could do that, certainly. So if you simplified the original function and changed it before you did the derivative, so 64y minus 2y squared, the advantage there is that it's now just a polynomial, and doing the derivative of that is probably easier. I'm going to stop writing product and just start writing p. So derivative, both derivatives would be the exact same info though, so it's not like you have to do one or the other. So we'd get 64 minus 4y, and equal to 0 or undefined would give us, what, 16?
Yeah.
And I'm kind of out of room. So 16 works good because I didn't even get any negative answers. But all this did was kind of give me a possible max or min. I shouldn't stop here because I don't know if this is correct or not. You have to determine if it's a max or min. How do we do that? Cassie, how would you figure out if this is a max or a min?
Maximum numbers around that number into the derivative.
You certainly can do that. So you're saying to use the first derivative test. And you would set up a number line and go from 0 to, I mean, honestly, you can't go past 64. Well, whatever. We could do 0 to infinity and then find out how it worked. But do you remember the other option? Because, yes, what you said was correct. You could just do first derivative test numbers, figure it out from there. No, okay. Does anybody else remember the other option for figuring out if it's a max or a min? It's an alternative way to determine that. Oh, I thought somebody would. Maybe you guys think you know it, but you're not sure if you're right or not, so you don't want to say it. Somebody want to guess it? No judgment?
The second group.
Yes. So you could plug it in the second derivative and look at the concavity to determine if it's a min or a max. It's always going to be up to you guys how you want to do it. My recommendation would be, if your derivative is terrible, I would do the first derivative test, because doing a second derivative usually is not very nice or easy. If your first derivative is pretty straightforward and easy, I would probably use the second derivative to determine max or min just because of efficiency. Either way works. And if you can't stand using the second derivative to figure it out, you can do all of them with the first derivative test. You could do all of them with the second derivative alternative test. It doesn't really have a name. It's kind of annoying. I'm going to plug it in the second derivative because I just wanted to use that way. So I would find p double prime, and I totally am out of space here, which is going to be negative 4. And in fact, no matter what number I plug into the second derivative, the answer would always be negative 4. So y equals 16 is going to be, is that a max or min? Negative concavity would look down. So that means anything with a negative concavity that's a critical number would be a max. Max at y equals 16. And our reasoning is that y double prime of 16 is less than 0. Emma? What should I actually answer for the question? I wrote down like proof and reasoning and stuff, but I didn't actually answer the question. What are we supposed to answer? Okay. What did we figure out?
One of the positive numbers,
Okay. Did we figure out the first or the second?
the second one.
Second, only because we wrote 2 times the second, so that's different than the first. Normally, it honestly doesn't matter, but in this case, they were kind of differentiated. No, don't want to use differentiated. Separated. So yes, how do we figure out the other one? Sure, where?
The secondary equation.
Okay. So we can certainly plug it in here. Otherwise, we can plug it in one right below it. The one right below it is already solved for x equals, and that's what we're looking for. So frequently, when you do your substitution with the secondary equation, the variable that you removed is going to be solved right there. It doesn't matter which one you plug it in, though. So like if you forget this, it doesn't matter. So if I plug 16 into that second one, I get 32? Yeah. So then I would say x is 32, y is 16. These two numbers would have the biggest product of all of the sets or all of the pairs of numbers whose first and twice the second equals 64. And it's very possible it's the only set of numbers. It doesn't have to be, but I'm pretty sure on this one it is. Now, it's an awful lot of writing. That's for sure. These questions don't go fast. But the general outline is going to be, oh, here, I'll highlight. I'll highlight for the video. Look at it, I'm getting like better at this. The general method is that you're always going to identify a primary equation, and that can be found when the question/sentence will ask you to find something that's a maximum or minimum. Like, that's always going to be tied together. And then there is always going to be a secondary equation that generally has numbers so that you can substitute information. And then your goal is to take the derivative to figure out max and min information from the derivative. Now, some of the details are annoying because sometimes there's constraints, sometimes there's not. Like, it's different for every question. So you kind of have to figure out what sort of answers you're allowed to have along the way. And it's not always super clear. So as you get answers, you can certainly kind of check things to see if everything works and is okay and, you know, whatever. This is going to be the general idea for all of these questions, no matter how different they are. Same process. I don't know. Anything about this one you want to ask about? Like, you guys didn't really ask anything at all. I know how everybody says no, like obviously it's different when you're trying to do it on your own. So like the kind of questions you should be trying to figure out for yourself as we're doing these, like as I explain them, is try to think to yourself if there is something you would be able to figure out or do on your own or not. And I know this had easy information. Should we just go right to another one and see how it goes?
Yeah.
Okay. Question 2. I think there's like 4 pages of notes, isn't there? We're obviously not going to do all of those. We'll basically get 2 questions in today. Who would have ever thought you guys would be at the stage where 1 or 2 questions an hour would be semi-normal? Think back to Algebra 1. Like, if a question took you a minute, you were absolutely, like, annoyed because it took too long. I know. Some of you will consider those to be the glory days. Back when you thought math was simple and awesome and easy. Math is still awesome. It's just not simple or easy.
It used to be free.
Yeah, it's just not simple or easy. But that's why you guys will get paid the most money. Because you're the ones who can figure it out and other people can't. Why don't you guys try to set up primary and secondary for this one if you can? And if you can't, we'll do it together in a couple minutes. If it helps draw a picture, FYI. Oh my, that was stupid. I almost took my actual pen and marker to write on here. Oh. I'm just going to draw the picture if you guys can't, picture it in your head, I guess. Oh, what? I can't draw a river in red. Is that brown? Let's do a fence in brown. That feels right. Maybe this is inspired by Yellowstone. That's pretty much what it's asking. You're building a fence, rectangular pasture. Here, we'll even draw the grass. This is my art skills being put to the test here. That gets old. I'm always impressed with artists who can draw an entire realistic picture with millions of these little marks. Because I get annoyed after just drawing a couple. Super realistic. Let's make that fence 3D while we're at it, since you guys are probably figuring stuff out. Drawing 3D is the only thing I know how to do. How are you guys coming? Are you just about there? This looks like a jail cell. A jail cell around grass. Are you guys stuck on primary and secondary yet, or did you move past that? Stuck on it? Okay. Okay. So we should start together, is what you're saying. Okay, so primary, secondary, and you don't have to call this primary and secondary, by the way. I just write that for myself. You can write whatever you want. This isn't a official real method or anything. You write whatever you want to help you separate information. That's the only reason I do it. It helps me organize. I don't want you guys thinking primary is a thing you have to figure out, but it's just organize the information on your own. What dimensions would require the least? So that is the word, well, I shouldn't scribble it out. That is the word right there that implies or infers max or min. So that's inferring least, min. So we would need an equation for amount of fencing. Because that's what we are trying to minimize, the amount of fencing. According to my gorgeous picture over here, our fence has 2 dimensions on it, X and Y, or whatever you want to call them. The area, wait. No, I'm not looking for the area of fencing. The least amount of fencing would be adding up the fencing. So what do I have? I have 2x plus y. Area is going to be our secondary information because that's the size of the pasture. Least amount of fencing means like perimeter, like smallest perimeter. Okay, does that help start it? Is that what you guys were somewhat stuck on? Maybe? Was secondary the easier one out of the 2 for this one? Hannah, what's the secondary one?
X times Y equals 180,000 square meters.
Perfect. It's generally always going to be the one that has a number with it. So if you're getting confused which one's which, it's pretty much always going to have a number. It doesn't have to, but it usually will. Okay, Ethan? What did you do from here? And maybe you even didn't get to, I don't know where you're at. What should I do from here?
Would you find one of the X or Y?
Okay. How do I do that? What you're saying sounds good. Find an X or a Y.
Would I do it on the secondary one?
Okay. How do you do that?
Just divide.
True. This might be super easy for you in your head. I guarantee some other people are looking at this and it's not. So just, if you can, tell me what to write down. If that's easier to explain.
So would you find like just say Y and then
Sure, it doesn't matter which one you do. Okay?
180,000 divided by X?
Okay, good. So to solve for y, I just divide both sides by x. Okay? Good, good, good. Do you want to call on somebody for the next step?
You can.
You guys are so kind. Who have I called on? Maria?
Now you can plug that back into the fencing primarily.
Okay, okay. I'm going to just make that F instead because I'm lazy. What would I write? But you're correct.
So 2x plus 180,000 divided by y, or x.
Mm-hmm. Mm-hmm. Should we call on somebody else? Do you want to keep going?
Okay.
I'm leaving it up to you. Either tell me what to do next or tell somebody else to do that.
Well, you can take the derivative of that now,
Okay?
which would be f prime is equal to
2. Good start.
minus
Minus.
180,000 over x squared.
Where did you get that from? I'm sure some other people are looking at that wondering what you did.
So if you make the 180,000 divided by x, like a power, not like a product rule, yeah, like that. So then you put the negative 1 in front, and then,
You basically did the power rule on that, wrote it so that you could do the power rule, and then changed it back to a fraction? Okay. Luke. Ooh, perfect. I wanted to just say it and see who's going to answer first.
You set that equal to 0?
Good. Make it equal to 0 or undefined. Okay.
yeah,
So if we make it equal to 0, we would add one term, and so it's just 2 equal to 180. Why I keep getting screwed up on how many zeros I'm writing. And we could solve it this way, and we'd get 2x squared by multiplying both sides by x squared equals 180,000. Divide by 2, x squared would equal 90,000, which I'm assuming when you take the square root is 300. Okay? technically plus and minus 300. Caden, we need some guidance from here. You have a lot of lost souls in here looking for guidance.
Yeah, do you just plug it back in?
I don't know. I was asking you.
I don't know.
Oh, well, you said plug it back in, but I don't know what that means.
Yeah, me
Oh, you were just trying to throw something out there?
neither.
Okay. It's not a bad thing to just do things you normally do if you get stuck. One thing you didn't tell me was where you wanted to plug it, so I didn't even know what you're plugging it into. How about I take a break to take some more Diet Mountain Dew so I can don't lose my voice, and you can get some guidance, like beg and plead from people around you.
Yeah,
Okay,
sounds great.
okay. Because I think a lot of people are at the same step as you, and they're not really sure what to do. So, if you guys hive mind it, you might be able to figure this out.
Yes. You, that's gonna be fine either, so you don't need it. Not yet.
Would it be easier to explain why I wrote down critical numbers was plus and minus 300 and 0?
No.
Oh,
Do you plug it back into the secondary equation?
that sounds awesome.
The second part of the secondary equation.
Okay, what would that find you?
I would find you y.
Oh, all right. 180,000 divided by negative 300 would give us a lot. 6,000? Negative 6,000? So, I feel like that's not right.
Yeah, it can't be.
Oh, good. Good start. So what should we have done with plus and minus 300?
Make it regular.
Good. Cross off negative. Good, good, good. Sometimes I'm following through with this because sometimes you need to get to a certain point before you realize it doesn't work. So plugging in negative 300 should have told you no, that's not cool. Also, can't plug in 0 because, yeah, 0 is kind of a stupid answer for a fencing mount. I mean, like, defeats the whole purpose of the question. Let's back up. Grace, I don't think you've gone. Why did I even have the 0 up there as a critical number? Because nobody said it to me, I just wrote it down. Oh. Do you remember how we found critical numbers? It's derivative something or something. There's nothing wrong with asking people around you.
Of the endpoint.
Ask somebody else. Critical numbers come from the derivative equal to 0 or undefined.
Yeah. I would, because it's in the denominator.
Good. Over x squared means you can't use 0. 0 would be an undefined value. Now this is kind of where the domain restrictions come in. We crossed off negative because a negative fence value is kind of stupid anyway. These have to be positive answers. And that's sort of the same with 0, and that this is kind of worthless to have a fencing answer of 0 because that would defeat the purpose as well. So all of our answers have to be positive, and then theoretically the biggest answer we can have is infinity. How come I could have an answer bigger than 180,000? I'm going to guess a lot of you would say 180,000 would be the biggest answer we could get for one of the two numbers. Let's say y is 180,000 feet, or meters, which is a lot. What would x would be 1? How could you make it so y would be bigger than 180,000? If x is less than 1? Now, those answers don't really make sense, but that's not our purpose to like decide that. We're just trying to figure out this situation, maximize area. So our domain is theoretically 0 to infinity. Oh God, I wrote it wrong. Now, obviously a giant number is stupid because it's not like you're going to put cattle in a fence that's a half a foot wide. But we're just going to set it up with like theoretical constraints. It's up to the farmer to decide if he wants to do it. Grace, do you want to call on somebody? Who hasn't gone yet? Luke hasn't gone. I helped you out. I called on Luke for you.
So what do we do next?
Yeah, that was pretty much what I was hoping for.
So we can either find y, or we could justify why 300 is a minimum.
Definitely the second thing you said.
Okay.
Because we don't even know if 300 is a maximum or minimum. I mean, minimum doesn't make sense because the minimum should be like 0. But
So
how
we can,
do we determine?
with the first derivative test,
Okay, we can do the first derivative test.
unless you wanted to take the second.
It's up to you. Thank you.
I'll just stick with the first derivative.
Okay, first derivative test it is. How do I do that?
So you set up a number line with 300.
Done. Okay,
So,
done.
and then
0.
you can then plug in a value in between 0 and 300, so like 5.
Into where? But yes.
Into the second, or into the first derivative.
Okay.
equation.
So 2 minus 180,000 divided by 5 squared, which is going to be a big answer. So 2 minus a big answer would be negative 1,000, I guess. I don't know. 2 minus 180,000 divided by 1,000 squared. That'd be 1.8, I think. So 2 minus 1.8 would be a positive answer. And absolutely feel free to use your calculator. I mean, obviously, if you could do it in your head, that's best and quickest, but. Oh, go ahead if you had a question. I don't know if you figured it out.
Yeah.
Okay. But yes, absolutely ask aloud if you guys run into something, not sure why I put it up here. So we were testing numbers before and after 300 to figure out if this is a max or min. Apurva, I don't think you've been called on yet. What did I just figure out? I wrote some stuff down.
You got the max, or wait.
You got a 50-50 chance from what you're trying to answer.
You got a min.
You got it. Whoa, really? You're correct. How'd you know that? Your brain. Your brain. That's a good answer. Decreasing to increasing is a min. Were we looking for a min or a max anyway? How do you know that?
Because it says least.
Nice. It says find the min, so we just did that. Okay. Cassie, have you gone? Dang. I don't remember who's gone or not now.
You.
I've definitely gone. I've gone way more than I should have. Poirez.
I've been done with the question in like 15 minutes.
What does that matter with answering the question? Are you saying I should have called on you earlier to guide them?
So I'm saying like, I think I'm like done my job.
Then be a better human and help the rest of your classmates because they need it.
Alright, so now that you know that x equals 300 meters is one of the values.
It is.
And you just plug it into like a y equals 180,000 over x, and you get 600.
That was the worst arrow I've ever drawn. What'd you say, 600?
Yeah.
Okay, excellent job. So plug it into that equation to find the y value, and you get 600, 108,000. And so then we would answer that the fence should be 300 by 600. Yes, ma'am.
Cause you, like, for the timer, cause you had x equals plus or minus 300, and you obviously know it can't be minus.
Yep.
I plugged it into the equation before, and I already got 600 and 300. And then it's obvious between the two, like, which is the min. So couldn't you just do that instead of?
No, you're not trying to determine between 300 and 600, which is min.
Oh, the overall equation.
So there's lots of different combinations of the fencing that we could multiply to get 180,000 square meters. We're trying to find the two numbers together that would be the smallest addition, like fencing. So, like, we could have given the answer of 200 and 800, but that would use more fencing than 300 and 600. So you're just trying to find the smallest pair, smallest perimeter pair.
So if we ever got x, would there ever be like a chance?
Wait, I'll pause. Are you asking me if you could have just tested the number right there?
Yeah.
No.
Okay.
I'll mark it wrong if you do that.
Okay.
So, on the AP test, if you get to this point at 300 and then you just answer it, you will get like 2/3 of the points. But they definitely dedicate a good chunk of the points to you trying to prove that you just found a max or a min. So I think that's what you're more asking.
Yeah.
Okay, true. So if you do this on the test, so like our test question, you'll get one like this. If you get to this number answer and you just like, in your head, you feel like you already know what it is, so you just write the answer at this point, you'll get about 2/3 of the points. Like, just because you came up with the correct answer, but you don't know if it's the absolute best answer. Yep, that basically took the hour, 2 questions. I'm sorry, Poirads, we will try to go faster for you. We are not as smart as you, all right? If you guys can, I would just start the homework tonight. Honestly, a lot of these questions they're the same setup, but there's a ridiculous number of different style questions. So try the homework tonight. Just try some of them, see how it goes.